Okay. Hi! Welcome to week 7. How are we feeling? Pretty good. We did. Yeah? It's week 7. It's ludicrous. It's crazy ludicrous. Hopefully we'll pull somebody's desks in before too long. People will trickle in. It's going to get harder and harder to come in here. I appreciate you being here. Now that those days are getting longer, it's getting warmer earlier. There's a lot of adjectives. Warmer earlier.
The sun is still up at almost 9 o'clock.
Yeah.
And I woke up at 5.
Yes. When I ride to the pool in the morning, I'm riding there at 5. And in the winter, I mean, it's like dead 20 degrees, cold, or negative degrees sometimes. Like this winter was really cold early. And then when I leave the pool, it's often still dark at like February and whatnot. But now, when I leave to go there, it's actually rising.
Right.
And I need 1 light, not 2. It's amazing. It's a whole north latitude thing. I'm actually giving a guest talk, speaking of which. Tell me if this is something 105 would benefit from. It's related to our discussion we had. We got that little tangent going last week about the oil. I'm giving a green building talk. With anybody in the forestry program? I don't think anybody's going to be.
Is it really?
No?
Yeah.
So, tell me if this is something, it would be tied into similar triangles. So it's not like I would be putting a whole new topic into 105. It wouldn't be for you guys. I mean, it would be for like the next class. Okay.
Yeah.
Enough! Not this term. I'm trying to, 105 is this moving target I'm trying to hone in on. Like, I think I know how the rest of your course is going to go for the rest of the term. I had all these ideas, like when I started the course with Equation Boot Camp, one of the reasons I started with that this term was I could see like this tree of ideas going out from that. And as we've gone up a branch, certain other branches have kind of fallen off. Like, okay, we're not going to get to that because I don't want to rush just to get to that. That can go away. So I think I know where we're headed. We're headed basically to randomness next, to probability next, and to craps last. And then we're going to kind of leave it at craps and expected value. That's kind of how we're going to end up, math 105. Down to one branch that consists of, and you might think, why are we going to play craps in class? Because once you understand how craps works and how Vegas sets payouts on craps, you're going to understand why your insurance costs what it does. See, this is the idea. That I kind of thought, how many of you are done after 105? It's a good-sized chunk of you, yes? No, it's not. It's less than half of you here. I wonder if that's... Okay, so anyway, I was designing it. I was trying to think of an idea to end up with so that those of you guys that are done after 105 at least take 1, if not 2 or 3 or 4 nuggets of information with you into your lives that you might at some point stumble upon in your life. That's why I try to tie everything back to a point. And usually the points they tie back to are understanding your world better. Not necessarily just like exactly applying a mathematical idea to something in your life. Like, you now know how a cop's radar gun works, but you don't actually have to do the calculations. You just have to understand the calculations, so if you think you've been unjustly tried for speeding, you can go explain the calculations to the jury and impress the judge, which is amazing. Every time I've taken a ticket to court 3 times. I've gotten 3, I mean, I'm old. I've gotten 3 BS tickets in my life. I don't drive all that much. But I got caught in a speed trap back in Delaware. I ran a stop sign that was covered with a tree back in Delaware, and there was a 3rd one somewhere in Pennsylvania. Oh yeah, it was tied to a stop sign too. And basically I was able to use mathematics in all those cases to show why mathematically it was safer to run the stop sign than to stop. For example, I did a force calculation. I was in the van. Now I told the judge, I mean, it was all honest. We had gear stacked on top of a loft in our van. So those of you that have a van or are going to pack your cars properly, when you pack your car, don't put heavy objects up high that have the ability to slide forward. This is what happened. I'm driving down the road in my van, Sadie, 1987 Ford Econoline, straight 6. Thing drove all over the country bus for years. Great van. We got a Marshall JCM 900 head. If you've ever picked one of those things up, they weigh, I'd say, 40 pounds, 45 pounds alone. Sitting up on top of this loft, skinny side forward. I'm going down the road 25 miles an hour. Now, I'm a math dude. I understand that if you step on the brakes, I understand physics a little bit. Object in motion tends to stay in motion. That's why in a car we wear. Because if the car stops, you don't. You don't. Object in motion tends to stay in motion. When that car hits something, you are not the car. You are sitting in the car. So you're going to continue to go forward at the same speed that the car was going when it struck. It's one of those amazing things. Einstein did a big talk about relativity back in about 100 years ago now. And the idea that when you're like standing on a train, walking on a train, And if you're walking forward on a train, the train's going 100 miles an hour, you're actually walking forward at like 102 miles an hour. Because you're only walking at 2. But that 2 has the 100 added to it because the train's going forward at that 2. So your object going through the air at 102 miles an hour. And in a car, hopefully not going 100, sweet Jesus. But that's the same idea of a seatbelt. So when I went to court and said I couldn't see the stop sign until I was on top of it because the damn branch was overgrowing it, I decided it was safer to blow through it than to stop. Because if I had hit the brakes right then, where's that JCM going to go?
In your head.
Into my guitar player's head, who was sitting in the seat right in front of the loft. I was driving. So I was actually out of harm's way because gravity would have kicked in. Then the thing would have left the loft. And then be under the force of gravity that you guys now have an awesome working understanding of after clocking me going down the hill. You got gravity, you got linear, you got the horizontal motion, vertical motion, parabolic motion, sleep-deprived motion. That was my guitar player in the back. So, I mean, the math I'm hitting you with, hopefully you can understand the world around you better. In little places, 10 weeks isn't a lot of time. So this flipping the coins thing right now, I kind of had an idea of where I wanted that to head. Flip the coin, the pull the cards. We're going to look at the United States population here a little bit, take a look at that, see how we can tie that back to our lives, why we care about that. Then we're going to look at disease spread. And we're going to see how all that stuff kind of ties together today. Well, hopefully we'll have enough time today to get through all those data sets. But I want to have that head towards probability, which needs an idea of randomness, which eventually will tie back to the game of craps. And have anybody played craps before? Okay, no, most of you have it, which is what I was hoping. Those of you that play it, do you understand betting? The most basic kind of betting, which is basically bet a dollar. Okay, kind of, sort of, kind of. That's okay, that's okay. That's okay, I expect you not to. So we'll learn the most basic kinds of betting in class, and we'll understand how Vegas makes so much money on the game. Because Vegas doesn't have to make money on games. They have to be very, very smart about how much they pay you. Very, very smart, actually. And if they screw up, Vegas usually doesn't screw up, but very often you'll hear stories about how a state lottery was overtaken by a citizen. It happened about 6 or 7 years ago in New York State. 2 kids made a buttload of money because the state changed the payouts on one game, and they didn't check their math, especially. And it turned out that on average, when you bought a ticket, you won money. You didn't necessarily win the game, but you won money on average over time. That's what I want to kind of finish up with, is that idea of on average over time, expected value, and how it relates back to your health insurance and your car insurance and everything else. Every other kinds of insurance you'll ever buy. You guys have to pay a premium on your insurance if you have insurance, right? You have to pay for car insurance, health insurance, life insurance. There's a reason you pay that amount. We always think it's too much. And sometimes it is. Sometimes it is. That's why you shop around and get better deals. But there's a mathematical reason why you pay that amount. That's what I want to get into in the last 4 weeks, kind of heading towards that. That's the branch of the tree I decided to take us down. However, the topic I want to ask you about is passive solar. I don't know if we talked about this in class with the whole oil spill thing. Because of the way the days are, because it's now getting late at 5 a.m. and it's staying late till almost 9. Longest day of the year? June 21st, summer solstice. Summer solstice, I think it sets right by Mount Jefferson. If you're looking in Bend, looking at finding the sunset, it sets right on Mount Jefferson. It rises up by Smith Rock, which is insane. I think I'm pointing the wrong direction too. I apologize for that. North. It rises far in the northeast and sets far in the northwest, where Bend is related anyway. Which is amazing. I mean, it's the same angle of inclination that it is in, it's the same tilt of the Earth's axis. But in the winter, in the dead of winter, December 21st, it's southeast and southwest, the rise of the sun. So it rises over here and then goes like that. Whereas in the summer, it rises back there, makes the same angle, it just gets much higher in the sky, hence having the whole idea of longer days, because it's in the sky longer. So you can design houses to actually heat. Does anybody have a passive solar setup in their house where the southern part of their house is highly windowed, lots of windows on their south side? Nobody's... Okay, so using similar triangles, you can calculate. Maybe some of you do. You don't even realize you do. It's possible. It's not code in Bend, which I think is a crime. I moved here from Delaware, where it rains like 5 feet a year, and the sun's hardly ever out. And when it is, it's like 100% humidity, and you want to be inside the air conditioning. But when I moved here, I'm like, oh my God, every house is going to have solar panels. Whoa, solar panels and hot water panels, and they live here all week. And I moved here, and nobody seems to, or at least they don't realize they do. When we built our house, I had to rebuild the design to put more windows on the south side. And what's interesting about it, the basic idea, I almost remember the screen again. The basic idea, if this is your south face, then just let me know if this is the kind of thing that would interest you as a math student, to see how it ties into life. Students always ask, what the hell's the point? I'm trying to kind of tell you. So, you got a south face of your house. It's facing south. And it's got windows on it. So, in the wintertime, you want to let the sun come through the windows. I mean, that's, hopefully you understand that. Our heating bill is usually about 25% whatever the average heating bill is for a house of our size in bed. Because we just cheat and we grab sunlight. And most of our house is heated by sunlight. I mean, it's just one of those things. You ever seen your cat? I mean, have cats this time of year when they find the sun, right? Sun comes in when they're laying there and they're on their back, just like, we open our front door, which faces east. So it's picking up early morning sun, and we crack open that door. That area goes up like 15 degrees. Just because that front door, which is dark green, has been getting the sun, and when you open that up and that radiates out, and the light comes and the cats go right down to the core, can just pass out on their side and lay there until the sun moves, and then they follow the sun. That's passive solar, so you want that sunlight to come in to warm your house. But in the summer, you don't. That's exactly the opposite of what you want, right? You want to block it. So the thing is, in the winter, the sun's down here, and in the summer, the sun's up here. Okay? So that's a winter sun, that's a summer sun. So in the winter, you want the sunlight coming through your window, because obviously that's the best case scenario. In the summer, you don't. So what you do is, you put what's called an eyebrow on your house, a little roof, a little mini roof. Well, I say mini, it depends on where you are, what latitude you're at. So based on the angle the sun gets to, this little angle right here, you can actually calculate where your eyebrow needs to be. Is that the kind of motivating mathematics that you guys might be into? Figuring out how big to make that eyebrow to make your house more energy efficient. Just a real quick show of hands. Yes, this sounds like, holy sh, okay, good. That's a lot of hands. Okay. Who says no? To hell with that. I hated that rabbit squirrel problem on the exam. Yes, because this is the rabbit squirrel-ish. This is the rabbit squirrel-ish. I mean, ish, if you think about it, it's maybe a little hard to see, but it's the rabbit squirrel all over again. So you've got a triangle right there, yes? And you've got an angle right here. This is 90 degrees, which means you can figure that angle out, because this one plus that one has to equal 90. So now you've got a little angle in here that you know. You know how big your house is. It's usually like 10 feet or so. If you measure your window, it's about 4 or 5 feet maybe, plus an extra foot for molding and things like that. It's going to be 7 feet. So you have to figure out what this is. So you know this, you figure that out, you know the angle, it becomes the rabbit squirrel, how tall is the tree. Just, if you can't see the rabbit squirrel, if you're looking at it, just go like that. And that's the tree, and that's the ground to the tree, and that's the angle that you tilt your head up to look at the tree. After explaining it, does that upset you and you don't want to talk about it anymore? Or would you still be like, yeah, this is kind of cool, we actually would maybe learn, okay, good, all right, I might throw that in. I might add that in next time around. Thank you. I was thinking about it as I was talking to Rebecca, who teaches forestry. And that's who I'm giving the talk for in about a week. Oh, if anybody's around, next Tuesday, we're having, the class is going to be at my house. What is it? It's 12:45 to 3:45. If you're free that time and you want to come learn about green building and green touches of houses, even retrofitting green touches to houses, swing by. I'll talk to me after class. I can give you the address. Her whole class is going to be over there for us for 260, and you're more than welcome to come over and drop in if you want. If you're interested, you might not be interested. If not, you're like, whatever, I like my house. And that's totally fine. But so thank you. Good. I thought that you might be interested in that. It's not related to what we're doing right now at all. It's kind of a different idea. Similar triangles and exponential modeling. There is no overlap at all. But it's a nice other branch of the tree to kind of build in Math 105. So good. Yay. Thank you. Good. All right, we'll stop there for now.